Hey there, Helium people. This is Peter, aka Hacking This and That. Um, Doing a couple of tutorial videos. I actually did this as a live demo in the IoT voice chat about a week ago, and it was mentioned during that hey, it'd be really cool if we could record these. So I figured I used to do this in a previous career, previous hobby, and haven't done it for a number of years. And just wanted to make sure that when I did jump back into this, I was doing it for the right reasons, and I really am passionate about this. I think this is important information for people to learn and understand. So this was a inspiration from some others, and yeah, we're going to dive in. In case you haven't figured it out, we're going to talk about the Helium console. So what is the console? Well, let's back up a step and talk about what it is we're building. So many of us are excited to grab hotspots, get them all set up, nice high location, antenna outside, good line of sight to other things, so that we can get the proof of coverage reward. But in the end, that isn't where the story stops. We are building a network for IoT sensors. And these little devices can be a variety of things. This happens to be an LHT65 Dragino humidity and temperature sensor. There's GPS tracking devices like this one, water and moisture sensors, sorry, water sensors, not moisture sensors. They're slightly different. And these devices get deployed by users of the network. So, how does that happen? Well, it all starts with buying a device and setting it up in console. So, this is going to be a quick tutorial on what is console, how does it work, how do we set up an integration so that the temperature on here actually can be displayed somewhere in an application dashboard app that we can then set up for our clients, for ourselves. Great way to start is actually, I love using these things. All of my hotspots that are deployed in outdoor housings have one of these in them, and that gives me the temperature and humidity inside the box. And with a external probe plugged into this, I can also then get the ambient air temperature outside of the box. So how does this all work? The first thing you want to do is go to console.helium.com and sign up. It's really simple. If you have a Google address, just to use your Gmail, it skips the whole registration process and just says, hey, this person's known here, fine, good, we're good to go. So let's add a device. Oh, how do we make this all work? That's an important thing. This little number up here in the right-hand corner you see as data credit balance. When you open a console account, you will get 250 data credits. If you take the survey and tell Helium who you are, how you intend to use the network, what kind of devices do you want to deploy, they will bump that balance up to 10,000 credits so that you can pass lots of data, maybe for a mapper or other device network. So let's dive in. Devices. This is where it all starts. You need to be able to register a device on the network. Dragino is really awesome because they will send you your mapper, or sorry, your sensor in this nifty little box. Inside the box is going to be a sticker. This has the keys on it. What I mean by keys is every device has to have an EUI identifier. There's then an application EUI, and then there's a app secret or key secret key. That's what proves your ownership of the device. The QR code that's actually on this will scan and will give you the first two, but not the third. It's important that it never gives you the third, because then somebody could just QR code scan your device and have all your keys. So we're going to go and add a new device. We're going to give this device a name. We'll say it's LHT65-1. The device EUI, I've already scanned, well, I took a picture of it, used Google Lens to do the character recognition and copied that from Google, and I will put that in the first field. The app EUI for some reason didn't scan. So fortunately with Dragino's temperature sensors, it's a really simple app key. So we need the letter A, obviously for app, I think, a bunch of zeros, and then a 100. And I'm going to come back here and I'm going to fill in a bunch of more zeros until I hit that 8 bytes mark. That's a complete EUI. And then there's the app key, and this I'm going to mask from you when I edit this up later. But for now, I can just go ahead and paste that in there and save my device. So now I've got a device registered, or at least entered into console. You'll notice that pending, and why my hesitation. What happens when a device is registered in console is it then has to talk to the router. The router says, hey, I'm now responsible for this device, and it will create a key using a XOR filter on the network. How this, or what this does, is as data comes across the network from my sensor to your hotspot onto the network, the router is going to turn around and say, hey, that's mine, I'll take that. That's done by creating this XOR filter. This can take some time to register. If you hover over here, it'll just say device is not in the XOR filter yet. But we have some things we can do while we're waiting for that to happen. One of the other cool features of console is creating device groups. So that's done using labels. So I'm going to go ahead and create a label. I'm going to call this label LHT65, and I'm going to do this for a reason, and I will explain that reason momentarily. Now I need to bind that label. Actually, you know what? I'm going to jump out. I'm going to go back to Y labels. So there is I'll call it a flaw in the firmware currently on these devices, in the fact that it will transmit packets on the wrong channels. And periodically what that looks like in console is you'll have packet number 100 and then packet 111, and it will have skipped 101 to 110. It's not that the device didn't transmit it, because as far as it's concerned, it has incremented that ID, and they threw it on the network. It threw it out into the world, and it was on the wrong channel for a hotspot to then receive it and process it, or somewhere further upstream. I'm not 100% certain on that. It's just not a desired thing. The fix to that is to flash this to the latest firmware. I don't have the right adapter, but I do have an alternate fix. That is done in Profiles. So I'm going to go into Profile, and I'm going to create a new profile. I'm going to call this CF-enabled, and I'm going to enable the CF list. According to this, it's only applicable to US 915 devices, so if you happen to be, EU 868 or AUS, pick a channel or pick a band. This shouldn't apply to you, but make sure you are monitoring your device. So go ahead and create this profile, and I'm going to go back to my device, still pending. Go to my label and settings. I'm going to add the CF enabled. So any LHT65s I add that I then apply the label to will get this profile. This is where labels and grouping is very powerful and very useful. So we'll go ahead and apply this change. Come back to all my devices, still pending. This can take a few minutes. I may actually end up pausing the video and circling back. We'll see how much stuff we can cover before I have to do that. So I'm going to go in here and I'm going to add a label, and I'm going to search for LHT65, add my label, and now we see that this has a profile. inherited from CF enabled from the group LHT65. So, still pending, not a problem. Other things that you can do here is alerts. So I talked about missing packets. What happens if I miss a certain number of packets and I want to be aware of that? This is where I can turn around and create a device label alert. I'm going to say this is missing packets. Alert admin when device stops transmitting for 1 hour. And you have a number of options you can choose here. So in my application, I am doing cold storage monitoring. I'm monitoring a refrigerator. A refrigerator can go from the food safe zone to outside of the food safe zone pretty quickly. So if this stops transmitting for more than an hour, I'm at high risk of missing a possible issue with my client's refrigerator. So I want to know if I have any devices that are not transmitting consistently. So I can create this label alert, which will now tell me that it'll send me an email that I am missing packets. Now, with that CF list, it shouldn't. That's actually how I figured it out. What else can we do here? Packets. Not as applicable with, say, a temperature sensor. You could if you wanted to. Or with a water sensor. But with something like a GPS tracker, especially if you're doing mapping, is how many hotspots would you like to accept and transfer your packet? If we're trying to map the Helium network, the more the better. So you can create a, we'll just call this Multibuy. I'm not going to do preferred hotspots. I am not a fan of the preferred hotspot functionality. I think that is a little misunderstood and maybe a little misused. People are thinking that if I set my own hotspot to my preferred hotspot, then I'll always earn the data credit. So I'm going to set this to buy up to 10 packets. And I say buy as in every packet that comes through is going to cost a data credit. Whether it's 3 hotspots that hear it or 10 hotspots that hear it, I'm going to have to pay out data credit to each of them. So we've got the packet config. Now, let's see if our join, no, still pending, not a problem. So we're going to receive data from our sensor. It is going to come across the network through your hotspot, hit the router. The router is going to say, hey, that belongs to Hack and this and that. Move that over here. It'll show up in console. From console, I then need to tell it what to do with it. This is where integrations come into play. Integrations are a great way to take your data and push it out to a dashboarding or visualization tool like Datacake. Great little tool if you want to get in and start experimenting with sensors, because you can get your first 2 devices for free. So you'll just go into the dashboard, register. I've already done that. I figure most people can figure out how to register for a service. And you'll come to your own admin dashboard. This is where we can create devices, reports, create rules, additional integrations beyond this. Maybe you want to start a business and you want this to be white labeled. That's all done from here. So from console, I need my device EUI, and I'm going to register that in Datacake. So Datacake supports more than the Helium network, but they are very well integrated with the Helium network. So I'm going to specify that I have a Dragino LHT65, and I'm going to go next. And as you can see, they support 11 different networks. We just need them to support Helium for now. It does uplinks and downlinks. That's going to be important. We'll cover that later. And we move into the next item, and we're going to tell it that this is our device, and we're going to call it LHT65-1. And we'll go next. And we're just trialing this out, so we're going to use the free plan, add one device. So we have a XOR filter that's being added to the router. We have a console that recognizes the devices when it comes in. We've got Datacake that recognizes the devices that it comes in. Now we need to tell console how to talk to Datacake. So that is really done all behind the scenes by taking the API integration key from your account details, going over to console, going into integration, and adding a new integration. We'll tell it a Datacake integration, and that we need to add, and we enter that API token. We need to give it a name. We'll just call it Datacake, and add integration. So all of the details about how the integration expects data from console is pre-configured. It's all done for you. It's so simple. And the downlink on how Datacake can now talk to your device is already pre-configured as well. So it uses this downlink URL and a downlink key, and we're done. We've now told console how to talk to Datacake. Now, there may be integrations you want to use that don't have the necessary data decoders built in. That's for functions, and what you can do is then take the data packet from your sensor, translate it into regular JSON, and push it into your integration or some other format. That's for a whole separate tutorial because it dives pretty deep into the nerdy end of the pool as to how to decrypt and decode the data packet. So let's see if our device is ready yet. Look at that. It is ready. So recapping, we have created our console account, we have added a device, we have let it register the filter for that device on the router and on the network. We have gone to Datacake, we've set up an account there, we've added a device, we have created the integration between console and Datacake, but we haven't actually told console what to do with our data. And that's where flows come in. This is literally drag and drop simple because we're going to take our label that we created and our integration, drop them on here, and just connect the dots. There. We now have a routing rule that says all data that comes through for the LHT65 devices will get routed through to Datacake. Now, a lot of other things can happen here. It's easiest to do here. I'm pretty sure you can brute force it through other ways, but if you click on this, you'll see this profiles. And CF is enabled because we have done it through the group. That's the sort of long way around. If you didn't do it through the group, you can then add it here. So we've now told console where to send our data. The only thing we have left to do at this point is actually send some data. So on these Draginos, little blue button says ACT. This is a multifunction button. So in this particular case, in order to join the network, I need to press and hold the LED will start flashing. I can let go. I get a red light, and now I go into my device, and I scroll down here to my real-time packet live data. So, any moment now, I am going to get a join request receipt back on my device, and this is actually going to blink red, but more importantly, you'll see it show up on this graph. You'll notice on here it's a time sequence graph, so as time passes, the little dots will move off the screen, but it also gives you an RSSI indicator as to the signal strength between the sensor and the hotspot. In order to not dox myself, I'm going to just describe the fact that if I mouse over one of those dots, it will tell me which hotspot received that packet. If I look at my uplink 0, again, I can look at my hotspot, but more importantly, I want to look at my MAC command. Oops. Sorry. On my downlink, my MAC command. So, I sent the sensor a channel mask. That's how we solve the missing packets. Also sent data rate. That's I'll save for another video. And then I got a single uplink, which confirmed my channel masks. Again, I can see which hotspot that it was communicating through. So at this point, I'm really just waiting for data. Multifunction button, hold it for 2 seconds, release, and there's my next packet. And just for fun, we'll do this a couple of times. There's another packet. The joys of multifunction buttons is you're never actually sure if you held it long enough. There we go. So we have received 3 packets of information from this through your hotspot onto the network, through the router, onto my console. It has gone through my flow integration, told it to send data to Datacake. Let's have a look at Datacake. I'm actually just going to refresh this page because there's a little indicator light in front of that sensor that hasn't lit up yet, and probably will eventually. It's just not real time there. And loading, green light. So that's telling me the Datacake has heard data for this device. And if I go in and look at this device and processing the data that it's received, it's telling you that it's 24.9 degrees in my office, 42.5% relative humidity, and an external temperature on the probe of 327.67 degrees Celsius. Obviously not realistic. Whenever you don't have the probe connected to this sensor, it sends a max value. There is a way to downlink a command to this sensor and tell it to not transmit the external probe, and then you just get the 2 data points. Additional data points that do come along with your data is your battery voltage, your uplink RSSI, your SNR, and your data rate. Data rate obviously is 0 because we've only sent 4 packets in less than a minute. It needs a little more time to calculate that out. Over time, you will get a nice trend graph on here, which will help visualize what's going on with your sensor. Um, there are a number of tutorials out, videos, etc., from Datacake on some of the other features. One of the things that I really like is the ability to make rules. This is how you then create actions that send, say, a text message whenever your water sensor detects water, or if your temperature drops below or above a preset temperature, send out an alert. You can do it by email, you can do it by text. I think with their integrations, you can also then integrate with some third-party service that could do an automatic voice recording message that says, danger, danger, refrigerator is over temperature. So lots of cool things you can do with that. But that is the essentials of how to get a sensor onto the Helium network and actually use the network for more than just proof of coverage. So more of these to come eventually. I just need to find the time and the topics. But if you are interested in getting into this and have questions, or need any assistance, feel free to reach out to me. You can find me as Hackin' This and That on Discord. And occasionally Twitter. That's about the only socials I do. But I'm on most days, all day, every day kind of thing, in and out. But yeah, hit me up if you need an assistance or have any questions. Until then, happy Helium and best of luck with your sensor